So in our last examples, we were given z-scores and asked to find the area under the curve. And we used our normal CDF to do that. Now, sometimes they give us the area already and want us to convert back to, find the z-score. So if we are given an area or / probability, the function we're going to use it's called inverse norm. And so our inverse norm, how we do this is we put the area, and it should always be to the left. So it's not always given to the left, but it should be the area to the left, comma, whatever the mean is, comma, whatever the standard deviation is, right? So a lot of times the mean is going to be 0 because it's the standard normal curve, and then sigma will be 1. So example 6 says find the z-score that has area 0.10 to its left. So it's saying 0.10 to its left. Now, if you recall, we know that if we cut this curve in half, this would represent, right, 50% of the data are 0.5, and this would be 0.5. So 0.1 is definitely less than this. So it's going to be, maybe somewhere, again, I'm not exactly sure, but, somewhere over here. We may need to, change our picture in just a minute. But this area that I shaded would be representative 0.10. Now, since it's already the area to the left, we don't really need to change it to the area to the left. So inverse norm, so 0.10. My mean is going to be 0 because it's the standard normal curve, and my my standard deviation is going to be 1. You're going to go and hit second vars. You're going to go down to the third one, the inverse norm. And I had said, right, it would be the area to the left. Now, with the newer calculator version, they have implemented a slightly new change. So you'll notice, right, the area, mean, sigma, and then they have the tail, right? So is this tail to the left? Is it in the center, or is it the right? So this is really handy. This means you don't really have to convert it as long as you tell the calculator which tail it's in. However, most of you probably have the older model, and they don't have this on here. So if you have the older model, all it's going to say is area, mean, and standard deviation, and then it's going to have paste. And so what I'll try to always do is sort of talk about both, but in this case, usually it's good to get in the habit of area to the left. That way, if you don't have this tail option, you're good. But for us, we're going to put left for the tail, and we will go down and hit paste and calculate that our z-score, right, we're finding a z-score, would be negative 1.28 roughly. All right, so if I were to sort of shade that in, right, I'm pretty close to sort of where it would be, right, negative 1.28. So that would be my z-score. Now, example 7, right, it says z of 0.35, and this is red, right, so it's a sub, so it's like 0.35 is what they're saying, the area to the right. So it's a area to the right. Okay, so area to the right, 0.35, it's going to be somewhere, over here. So 0.35. Now, I guess if you have the newer calculator, you could go through, and I'll write this down. So it would be inverse norm. So 0.35. You'd have your mean of 1, standard deviation of mean of 0, standard deviation of 1, and you would say this is to the right. Okay? If you have the newer version like I have on my emulator. Now, if you have the older version, we need to calculate the area to the left of this. And we do this by finding 1 minus what we have. So if we take 1 minus 0.35, we'll end up with 0.65, but 1 minus 0.35. So we'd end up with 0.65. And this is the area that we want to put in the calculator if we don't have that center, the tail button on our calculator. So we do inverse norm of 0.65, 0, and 1. Okay, so just depending on the version of the calculator you have is going to sort of depend on how you enter this, but we should still end up with the same value. Over. So if I hit second distribution, go down to inverse norm, We'll hit area is 0.35. The mean, right, is 0. Standard deviation is 1. And I'm going to type in right here. So I'll hit paste. Now, if you have the older version, you're going to hit 0.65, 0, 1, and just hit enter. And you should still end up with the same z-score of 0.38. Okay? Or 0.38, let's do 5. Okay? So, just depends on the calculator that you have. If you have the newer one or the older one, sort of how you enter this in. Okay? So our last example with this idea of using the inverse norm, it says find the two z-scores that divide the standard normal curve into a middle area of 0.95 and two equal outer areas. So we know that 95% of the data, right, lies within 2 standard deviations from our empirical rule. So we know, right, that this is 2, right, 0, 1, 2, -1, -2. So we're looking at this area here, and we want to know the z-score. So in order to find this, we need to find, again, if you have the older version, we need to find the tail, right, the shaded to the left. So if I know this is 95, right, 95%, we know that the tails, right, I have 5% left. And if I take the 5% and divide it by 2, right, I end up with 2.5%, or in the tails. And that is a probability, right, would be 0.025 if I divided by 100. Okay? So if you have the older version, I'll start there. So inverse norm, you would type in 0.25. You would type in 0 and you type in 1. And that's going to give you the lower z-score value. That's going to give you what this value is, you know, right there. Okay. So if you have the newer model, you can do inverse norm. Inverse norm. You can do 0.95, right? That's the center. You have 0, 1, and then you're going to have to tell the calculator that it's the center. Okay, so let's take a look. So I have second bars, go down to inverse norm. We have, so I'm going to do, since I have the newer version, 0.95, use 0, 1, and now we're in the center. And we'll go down and paste. So my calculator gives me the two values. If you have the older one, it's going to give you this lower one here, -1.96. So if you recall, since the curve is symmetric, if you find the one negative, it should automatically be the opposite value. So if you find the lower one is -1.96, you can also say the upper one is +1.96. Now, what we know with the empirical rule, right, we had approximated this at 2. So remember, empirical rule is not quite exact, right? It's an approximation. The exact z-score values would be -1.96 and +1.96.